Snow seems simple. It's white, it's cold, it's flaky. Or is it? What if I told you snow is more remarkable than it looks? It can twist and scatter light, it can change colour, it can soften sound, and it can trap heat, creating a hidden, warmer world beneath your feet. And what controls all of this is something surprisingly simple. In this video, we're exploring things you might not know about snow, using a few simple demonstrations to show how snow interacts with light, colour, sound, and heat. First, snow isn't white. It's true that it appears white from a distance, but it's not made up of white stuff. Up close, a single snow crystal is completely translucent, like a shard of glass. It's only when you bundle lots of these crystals together that something magical happens. To prove it, let's do a quick demo. This is an ice cube. Shine a torch through and you can see the light pass straight through it. Now, I'm going to crush this ice and see what happens. Suddenly, it appears white, scattering light in every direction. That's because crushed ice, like snow, is a perfect light diffuser. Each crystal has countless ice-air boundaries that scatter light. When many of these crystals sit together on the ground, all wavelengths of light are scattered equally, and we see white. Snow doesn't look white because it has a colour. It looks white because of how it handles light. So, what would happen if snow did start to take on other colours? Yes, we've all heard of yellow snow. But snow can also appear blue. Deep or compacted snow takes on a blue hue because ice absorbs red light and scatters the blue back to our eyes. Dust, pollution, or even tiny freshwater algae can also transform its appearance. Have you ever seen watermelon snow, also called pink, red, or blood snow? In this phenomenon, the snow blushes with a reddish or pink colouring thanks to a cold-loving species of algae which thrives in freezing water. You'll often spot this colourful snow in alpine and coastal polar regions during summer, when melting snow creates the perfect environment for the algae to flourish. This can significantly darken the surface, reducing the snow's reflectivity and causing it to absorb more sunlight and heat. In other words, watermelon snow melts faster, which can impact water supplies and contribute to climate change feedback loops. But light isn't the only thing snow interacts with. Fresh snow can change the way the world sounds. If you've ever stepped outside after a fresh snowfall, you may have felt it, that almost enchanted quiet that settles over everything. The world suddenly seems softer, muted, as though someone has gently turned down the volume. In fact, the Japanese language has a word for the soft sound of falling snow, shinshin. Shin refers to the silence, or more specifically, the absence of sound where there was sound before. But what gives snow this magical muffling power? The secret lies in the snowflakes themselves. Each one is a tiny masterpiece, an intricate six-sided crystal filled with pockets of air. When countless flakes settle and stack, they form a fluffy, porous blanket. Those air-filled gaps act like nature's soundproofing, just like the foam panels lining this weather studio. But step onto that snow and it's far from quiet. On very cold days, when the temperature is well below freezing, the ice crystals are stiff and brittle, snapping under pressure as you walk and producing that satisfying dry crunch. Closer to freezing, snow is softer and wetter. The crystals are coated in a thin film of liquid water, so they squash and squeak instead. Snow acts in a similar way, and to prove it, I've got some fake snow here. I can sprinkle into this bowl. Just add some water. Now I've got my fake snow. I can compare the sound this bottle top makes when it hits wood versus snow. When sound waves hit this soft, airy surface, they don't rebound sharply. Instead, they seep into the tiny spaces between crystals where they scatter, weaken, and gradually fade. the world becomes quieter, almost serene. Scientists measure sound absorption on a scale from 0 to 1, and fresh snow ranks surprisingly high, between 0.5 and 0.9. So a layer of snow outdoors can have a similar muffling effect to thick carpets indoors, soaking up a lot of the everyday background noise. The same air pockets that dampen sound make snow a powerful insulator too. As long as snow remains loose and fluffy, it slows the escape of heat remarkably well. That's why explorers caught in a storm can survive by building snow shelters or hollowing out deep drifts. Beneath the snowpack, this insulating effect creates a hidden world known as the subnivean zone, a narrow space between the snow layer and the frozen ground that stays close to 0 degrees Celsius, even when the air above plummets far below freezing. Small mammals like mice, voles and shrews take full advantage of this cosy microclimate, carving intricate tunnel networks that keep them warmer than they'd ever be on the exposed surface. But this dreamy, muffled world is temporary. As snow compacts, melts or refreezes into solid ice, it loses its delicate air pockets. The surface becomes harder and more reflective, bouncing sound back instead of absorbing it, sometimes making winter landscapes feel even louder than before. Why does snow have these remarkable properties? Why can it scatter light, soak up sound and trap heat? It all comes down to shape. Every snow crystal starts the same way, as a tiny six-sided structure. That hexagonal shape comes from the way that water molecules lock together as they freeze. But from there, no two journeys are the same. As a snowflake falls, changing temperature and humidity sculpt those six sides into an astonishing variety of forms: plates, columns, needles, stars. And, crucially, those shapes are full of air. When many of these six-sided crystals pile up, all those edges, gaps and pockets of air create a material that's brilliant at scattering light, absorbing sound and slowing the escape of heat. Change the shape by compacting, melting or refreezing the snow, and all those properties change too. Snow isn't just white, and it isn't just cold, and it isn't just frozen water. It's a vast collection of tiny six-sided crystals shaped by the atmosphere, packed with air and endlessly variable. Once you start seeing snow this way, a snowy landscape stops being just something you look at and becomes something you can read. If you'd like to dive deeper into those shapes and why snowflakes come in such extraordinary varieties, we've got another video exploring exactly that. Click here to watch that, and if you enjoyed this video, let us know in the comments. Make sure to like and subscribe for daily updates.